Hello, everyone. And now let's talk about the solid principles. These are the five design principles that make developers to create maintainable, scalable, and robust software. These principles make code easier to understand, modify, extend while reducing the risk of introducing the bugs or the unknown errors. Because if you have well formed code, then there are few chances that you will introduce any bug in your application. So, first principle in a solid is the single responsibility principle. A class should have one and only one reason to change in a single responsibility principle. In our upcoming videos, we will see that what I meant by this definition. But let's try to understand the definition with the help of this class diagram. So, for example, I have an employee class, and you are handing over the responsibilities of calculating the pay, saving your employee information and printing the report to your employee class. So when the responsibilities are combined in the same source file, the collisions become more frequent and you make your class more dirty and polluted in this way, right? And now let's build a demo for the solid principle implementation, and we will see that while designing the classes, writing the functions, creating the relations between the classes, how we are violating that principle. So first I will create a new project here. I will choose the class library, right? And then I would say solid underscore principles, right? And I will create a project, and I will create a same class employee which I showed you earlier in my diagram. And in this class I will create multiple responsibilities, right? So public void save employee, right? And then I will create one another method, public void print payroll, right? And then I will say public void calculate salary. So you can see here that I am handing over the different responsibilities to my employee class, which is clearly the violation of SRP, because in single responsibility principle, class derive the changes, right? So if you are handing over the multiple responsibilities to your class, then the changes will occur on multiple places, right? So in order to correct the issue here, or in order to prevent this SRP, what I will do, I will create one another class, public class employee repository, right? And in my employee repository, I will save the employee, right? And the same cases with the print employee payroll, right? So I will create a separate class for that as well. So let me create quickly print payroll, and the method is the same, right? And whenever I will instantiate each of the class, then I will pass the parameter uh, for the employee class in each method, right? So basically, the responsibility of employee class is just to provide the demographic or any personal information related to the employee. It is not the job of employee class to calculate the salary, save the employee, or print the report, right? So this is the violation of SRP when you are designing the class. And now let's move one step further and try to build the low cohesion between the classes. Because when you are working in SRP basically enforce you to have a high cohesion between the classes. But if you ended up a low cohesion, then that is the violation of the SRP also. So let's build an example here. I'm going to copy this class and let's paste it, right? And let's say it low cohesion SRP, right? And let's get rid of these all the classes. Okay, so now what we are going to do, suppose I have a class called order management in fact. And in my order in management I have a method called public void validate order, right? And in my validate order I will take the input for my order class, public class order, right? And over there I'm going to take the order. And now over here what I'm going to do, I will say if and put the property here, uh, integer, and say order amount, right? And I will say that if the order amount is less than or equal to 0, right, then console dot write line, for example, and say invalid order amount. This is the validation I applied here. The second thing which I will do here, uh, I will add calculate discount method. Let me copy this one and let's do it quickly, and then I'll say save the order. I will change the name of the methods afterward and then send the email to the customer that order has been confirmed. So let's change the names of the method, right? So one is the calculate discount, save order, and send email, right? And let's get rid of this line and this line here and this line here. So you can see here that my order management is doing multiple things here. My order management not only validating the order but also calculating the discount, saving the order, and sending the email to the customer. So this approach is basically the violation of the SRP because you are building low cohesion between the classes. So when I will create the instance of each of this class, then you can see here it looks nice to have one order management class which will be doing multiple activities related to the order. But actually I'm violating the SRP because this is example of low cohesion. Because if my methods keep growing and my functionality keep growing, so I will keep making that class polluted and keep increasing the complexity in this class, and if I would like to apply the unit test over there, then definitely it will be very difficult for us, right? So now let's solve this problem and see that how we can get rid of the low cohesion uh, in the situation like this. So to prevent the issue of the low cohesion, I have created a high cohesion example here, and I distributed the responsibilities by dividing them in different classes. So all my order validation will happen here, my discount algorithms will happen here, and my order CRUD and notification will happen in their relevant classes. And then there is one another class called order processor, where I have injected all the dependencies, and there is one method called process the order, and I'm just validating the order and proceeding with rest of the other activities. So when I'm going to utilize this class, then I'm ended up a well patterned and well formed code. So for example, if there is any change in the discount, then it will happen in its relevant class, right? So in my previous example, if there is any change in the discount, then it will happen in one class, and there are high chances that you will ended up uh, bug. You will introduce a new bug, right? So you can see that how high cohesion adds the values. SRP always promotes the high cohesion because you ended up a well structured and well formed code. If you have well formed and well structured code, then you will not introduce any bug while making any change in your application.